Hi folks. Okay, so today's topic is human factors and usable security. So today we're looking at the way that security mechanisms can be designed in order to fit with uh, the capabilities and the limitations of humans. And so what we're starting out by looking at, we're trying to understand what the human factors are that are related to cybersecurity. So first we'll start with the definitions and contextualizing the topic. Then we'll look at fitting the task to humans, and then we'll take a look at the limitations and capabilities of humans, and some of the capabilities and limitations of the devices that we use in order to provide security mechanisms. After that, we're looking at how we can actually work on improving cybersecurity by taking a human-centric approach. So there are one of the leading causes of cybersecurity issues is human error, is usually described as human error. But then we'll take a look at positive security, which is a different approach to looking at cybersecurity issues and taking a more positive spin rather than trying to assign blame to humans. And we're trying to look at more positive ways of framing the idea that will lead to higher stakeholder engagement. So stakeholders are the people that are that have an interest in a organisation, a project, or a business, and we want them to be engaged with the security process. And to ideally, the ways that we actually address this is through increasing awareness of cybersecurity issues and education and training. So we'll go into the differences between those things later in the lecture. So human factors. So human factors is the study of human interactions with technology. So it's a general field. It's not necessarily just related to cybersecurity, but we are looking at how cybersecurity relates, how humans, the limitations and the capabilities of humans relate to cybersecurity mechanisms and the design of good cybersecurity mechanisms that do not that are easy to use and that fit in with people's the things that humans usually do during their tasks. So there's a diagram here from the CyBOK human factors chapter, and essentially it models. Basically, it shows that humans. It shows that there's a picture of a human there, and it shows what they can do. So the human is trying to ultimately achieve a goal, and in order to achieve a goal, they carry out some tasks. In order to carry out the tasks, so they exist within a physical context and a social context, and humans have a combination of cognitive and motor skills, and there's a breakdown of different types of cognition in there. So you've got like memory, short-term and long-term memory, episodic and semantic memory, the mental models and the decision-making apparatus that humans have. And essentially, humans going about trying to carry out its tasks to achieve its goals, and there may be adversaries that are trying to exploit the human into along many of these different ways. So one of the ways is it can exploit the social context, or there's another arrow here that shows that they can aim to alter perceptions in order to mislead you and or make your life more difficult. This can include things like scamming and like social engineering attacks, phishing, things like this. So human factors engineering is a sub-branch of human factors. It's actually all about creating systems, like designing and building systems that are optimized for human performance, health, safety, and security. So examples of this human factors engineering are things like ergonomics, so like the design of devices that fit well with your hands. Like you'll probably be aware of like ergonomic mice and keyboards, like human input devices that have like a bit of a shape to them, so that your wrists don't rest in uncomfortable or like potentially positions that may potentially damage them over time. Other examples are things like accessibility, so designing systems in a way that people can use them, people who may have disabilities, so for example visual impairments or hearing impairments. You want to design a system so that people, so that everyone can use it. So that might include introducing things like screen reader technology that, for people who are visually impaired, or larger fonts, for example. So usability. So we're trying to create systems. We're trying to design systems that are usable by the people who need to use them. We're trying to do so. We're specifically looking at cybersecurity, and this covers things like social engineering, usable security, and there's a little image. So usable security. What do we mean by usable security? So this is just HFE, the human factors engineering for cybersecurity. And what we're trying to do is develop user-friendly interfaces for whatever systems that we're using, to essentially attempt to create systems which improve the security but maintain usability. So this is usually modeled in a triangle where there's a trade-off between usability, security, and functionality. So usable security, we're trying to design based around what humans naturally do well and what they do badly. So we're trying to create user-friendly interfaces and processes. The goal is to try and improve the adherence to security policy and mechanisms by reducing the friction required in actually using a system in a secure manner. We're trying to reduce cognitive load because some security mechanisms can overload cognitive function. Things like complex passwords. We've got solutions for that, like password managers. Things like, for example, authentication codes. Most of them you'll see are around 6 digits long nowadays. In the past, they usually just stick to digits, but there are issues where you can make it more difficult. Originally, some of the designs were longer than 6 characters. So they mixed letters and numbers, and it was just harder for people to keep track of what they've just read as the authentication code and then type it in. So in usable security, we're designing things that are actually easier for the end user to do. And we're also trying to improve accessibility to systems as well. So fitting the task to the human. So usually, rather than trying the opposite, which is to fit the human to the task by creating a system that's not necessarily well designed from a usability perspective, but that is secure, it's an uphill battle trying to get humans to use it in a secure manner. It's a lot better of an approach to try and go the opposite way. So trying to adjust and amend the task that's being done in a way that fits with what humans are able to do and what they're not able to do as well. So this may be. So we're trying to come up with secure designs that are aimed at fitting with what humans can do, what they can't do as well, the capabilities and limitations. We're also looking at the way that humans operate, which is from a goal and task-oriented point of view. Generally, when you're, generally you'll have an overarching goal and break it down into subtasks. We don't want necessarily to have our security mechanisms create a bunch more tasks for the user, because then it becomes a nuisance and it's more likely for people to try and bypass it. We're also looking at the physical and social context of use. So as working conditions have changed over time and we're now taking a more remote centric, we've got remote working now, especially since lockdown. There was a massive uptick in remote working, and what does this, and we also have mobile devices, and the whole working environment is no longer centralized in an office. You go to work, you do your work there, then you go home. Now there's a much wider, the context is expanded, and some of the processes may need updating to reflect the new use. There have been some incidents that I'll talk about in a bit that where this becomes relevant. And after that, we're looking at the capabilities and limitations of the devices which the security mechanism is being used on. Okay, and there's a little cartoon here that you can read, which is quite funny, from Dilbert. It's related to usability. So, fitting the task to the human. So, for example, two-factor authentication. This is a decent example because it's changed over time and improved with usability. I kind of covered one way it's improved, where the passwords are now much more user-friendly. But another way it improved is that with the wide adoption of mobile devices, like most people have a mobile device now, you used to get sent from your bank a little device like this, in some cases, which was a physical device that had like a cryptographic algorithm within it that was based on what the current time was, and you also, so basically it'd like produce you a code. It works in the same kind of way as a lot of the multi-factor authentication things you do with your app. Like they work in the same way. They're both generating codes and then checking them. But it's like two different. So from the server side and from the client side, or the device side that you're authenticating with, both of them are running the same cryptographic algorithm that that are based on the time, and if the codes match, then the authentication is accepted. So there are other improvements. So for example, with our uni logon system, you've got the ability now to rather than have to prove that you have a so now rather than having an actual physical little device like this one in the image, everyone's got, well, most people have a phone now, and in having that phone and demonstrating that you have that phone, that's another layer of authentication. So yeah, you'll enter your password and then you'll also prove that you have your device. So that's become a lot easier. There are also some mobile authenticators will literally just pop a notification up, and you'll have to either log it into your device with your device's PIN, or you can even use biometric options, so like fingerprint scanners and facial recognition options. So it's become a lot easier to do multi-factor authentication over time. And fitting the task to the humans is not always aimed at improving the user experience. So sometimes some of the limitations it's not always about identifying the limitations of the humans and then trying to build software to help them. In some cases, they're like in the instance of dark patterns, so user experience design. Here's an example, basically from an old version of the iPhone, which has a dark pattern in it that is intentionally misleading in the way that it's phrased, in order to make you think the opposite of what is happening. So in this example, we've got limit ad tracking off, and when you read something about ads and you turn it off, you're thinking, okay, well, that's going to be you're opting out of the ads. Actually, in this case, the setting is called limit ad tracking. So if you turn it on, it'll limit the ad tracking. But there are a bunch of things like this, usually in privacy settings for social media companies, where their goal is essentially to get you as much data out of you as possible, and it's not beneath them to trick you into doing that. So yeah, this goes back to the phrase that you've probably heard before, where if the service is free, you are the product, and they're trying to get as much value out of you as possible. So we'll go over some examples of human capabilities and limitations. So we're talking in general at the minute. We're talking about the general capabilities of an average human, and exceeding the limitations can lead to security problems. So some of the capabilities: we're good at pattern recognition, we're good at learning and adapting, we're creative, we can solve problems, we're intuitive, we have the ability to think critically. And some of the limitations, we've got things like short-term and long-term memory. I gave the example before of the short authentication codes. Cognitive biases. So this comes into risk assessment. It's actually really difficult for humans to evaluate risk well. Attention span. So this is a problem that's becoming worse and worse over time with the rise of apps where you're just constantly scrolling. People's attention span. There've been studies which show that over time the average attention span has dropped significantly, and it's suggested to be linked to like social media use and the way we interact with technology in the modern age. So that's something that you need to be careful about when you're designing systems. You don't want to overload people's attention. So fatigue and stress. So humans, as opposed to machines, can obviously get tired, stressed. We're not consistent in our behavior. We have moods. Like it depends. Like behavior can be impacted by mood and physical health. So lack of knowledge. Maybe the individuals involved don't know enough about the topic. So this becomes in lacking the knowledge. We can't expect them to have a full understanding of the situation. So like this is where education comes in, and training and awareness raising. And there's also information overload. So if you bombard someone with too much information at once, the brain tends to shut down. I'm sure it's happened to all of us when we're going through a particularly like difficult technical topic. Sometimes there's just too much information, and you need to take a step back and take a look at each piece individually. So that was talking in general, but there are also the needs of specific groups that we need to address. So if we've got some kind of mechanism, some kind of security mechanism in place, or even just any design in general that's targeting that children or elderly people need to engage with, they have differences that diverge from the average in terms of like motor function. Maybe they might not be able to quite press a small button quite as well, so you need to design with that in mind. There's also disabilities, so visual impairments. I mentioned this before, but we've also got things like colour blindness. So some old captures would include like red and greens with where they were mixed, and it's quite difficult for people who are colourblind to distinguish and like authenticate that they weren't a robot. So yeah, hard of hearing, mentioned that before. And then there's also more specific conditions such as like autism and epilepsy, where people might be impacted by particularly loud noises or flashing lights in negative ways. And there's also the cultural context of whatever application that you're building, or whatever system that you're building needs to fit with the cultural norms of whichever demographic or population the system's going to be used by. So goals and tasks. So humans are goal-oriented creatures, and as I mentioned before, we generally break larger goals down into a series of tasks in order to complete a goal. So there's primary tasks and enabling tasks. So primary tasks let's think from the perspective of an employee in a business. So the primary tasks are the core tasks that are involved with an individual's job role, pretty much. So it's like, and enabling tasks are ones which are not necessarily required for the job role, and they're usually seen as like extra work. And these can be things like safety and security. People will cut corners if they don't feel it's essential. If it might be, for example, if it's too burdensome to, in their opinion, to follow a security mechanism or some health and safety procedure, they might skip it because they might not think may see it as an unwelcome additional work, or they might not really understand quite why the policy or procedure is in place in the first place, and just think it's not a big deal if they skip it. So good security design, usable security design, tries to design around the primary tasks and incorporate the mechanisms within the primary tasks rather than having extra tasks that you add on. So we want to try and minimize the amount of extra work for the users. So as an example, using authentication as an example, let's say that an employee needs to authenticate to get onto the system to do their job, but they've forgotten their password. So this is a routine task, authentication, logging onto your system in the morning happens all the time. So it's a primary task. But if the task fails, there are a number of new tasks that get spawned. So rather than just recalling the password and entering the password, just two subtasks, you now need to talk to the help desk. This could take a while. You might have to physically go to the help desk or ring them. You might have to keep ringing them if they're busy. This could take a while, let's say like 20 minutes to get your password sorted. Then you need to come up with a new password, that meets the password policy, and you need to memorize a new password. Then you need to go back to your machine, recall the password that you've just memorized, re-enter it. So all of these extra steps within the process are expensive for the user, it's inconvenient for them to have to go through that in order to get a new password or a password reset. So this can lead to workarounds, people working around the policy by like writing passwords down, for example, or reusing passwords, or even like preventing themselves from being locked out often. So some organizations have policies where the screen will lock if you. This is good practice to have this, where screens will automatically lock if you're away from keyboard for a bit, you're not putting any input into the system, and this is just so that if you aren't at your system, somebody else can't come along and start using it. So sometimes you'll see things like anti-screen locking, some mouse jiggling software, or even things like this. So here's an example of somebody using this drinking bird thing that swings, and the tail rubs over the mouse, so that the mouse moves, the cursor moves, so that counts as input, and it keeps the screen unlocked. So yeah, people will come up with all sorts of creative ways of bypassing security mechanisms if they perceive it to make their life easier. So that's what we're trying to prevent. So physical and social interaction context. So this matters because the contextual environment will impact performance and security. So as I mentioned before, the modern environment's changed over time. It used to be centralized within an office environment, but now we've got mobile devices, we've got remote access, people working from home, people working on the move, for example on trains or in public places like cafes, coffee shops. So the new context developing will reveal issues with data mechanisms and policies, and those should be addressed and updated. So for example, there are a few cases of oversharing. So one that will apply to most people online is that common security questions used to be things like your mother's maiden name, your first school, date of birth, things like this. And a lot of that information is now publicly available online because people overshare on social media. They'll sign up to services which use these common set of answers. So even if, for example, you haven't publicly posted your mother's maiden name on any of your profiles, if that's been a security question for another service that has been compromised and they weren't storing the question and answers securely, like using hashes and salts, if it was just in plain text on a server and then that server gets compromised, there are lots and lots of dumps online that you can find where people have compromised the system, dumped all of the credentials, so all the accounts and emails that are associated with that have signed up for these services, and some of them even include answers to secret questions. So these are things that you can find online. You can either find them from just open source intelligence, just having a look around and trying to piece together information that's out there, or even like these are targets for people to socially engineer. So like they might ask questions about what, like, your dad's middle name. I don't know. They may people are tricky and they frame stuff in ways that try and mislead you. Anyway, here are a couple of others. The two at the top are links that you can click on and read yourself. They're just news articles. Essentially, the second one down, secret terror files left on a train by a senior intelligence official in the UK. So this was a pretty big story back in 2008, where some data got left on a train. So the next one down was the former NSA and CIA director Michael Hidden. This was one that was not too long, well, 2013, 10 years ago now actually, but this was a big deal at the time, where someone on Twitter, someone was sat on a train and the former CIA and NSA director was having a conversation off the record to somebody about, I think it was about the Obama administration, criticising Obama or something like that, and you can check the details yourself. And someone on the train overheard them and started tweeting what they were saying. So that's another thing. And this one I'll just quickly pull the video up for the third one because it's quite... Okay, so here's the link for the third one. So there's a video, this was quite recent. It was posted recently, 2013, September the 11th, but it's footage from 2019. So there's a police officer sitting in his patrol car. The environmental context that changed here is that police are now all wearing body cams, right? Or body cams are widely adopted in police forces nowadays. And here's a video of the police officer recording himself typing his password in, and yeah, so VX Underground shared it. The body cam footage shows him typing Sierra $123, and yeah, hopefully they've changed the password since 2019. So there's a bunch of examples of this kind of thing where they will not realize that there's a security incident that's happened here. This is probably body cam footage that's been released related to some case, and they've accidentally leaked the password. So physical environments and conditions can also impact the usability of certain security mechanisms. So this is things like the light, the level of light can impact facial recognition. Noise conditions can impact voice recognition. Temperature can it can impact the function of fingerprint scanners, but it also can impact the physical the human's ability to operate the devices as well. Because if you've got cold hands, you work slower. Maybe you'll even put gloves on, which may, unless you've got those gloves which let you touch the screen, might require you to take your gloves off in order to then enter your password and put them back on. So things like pollution, dirt and moisture, these can impact sensors and touch screens as well. So looking at the device capabilities and limitations, we've got things like we're very used to smartphones, but some people still use old school dumb phones, I guess, and these don't have the capabilities that some devices do. So you wouldn't be able to have a fingerprint scanner or any facial recognition or authentication apps on it. We looked at hardware authenticators before, so they're quite difficult. They're cumbersome to carry with you because they're like bulky things, hard to fit in your wallet. Most of them are like, you probably wouldn't be able to fit it in your wallet. You've just got to carry this extra thing on you. If you lose it, then you've got to go through a whole bunch of tasks to get another one, and you'd be locked out of your account, so that's a problem. So screen size for visually impaired people, and some devices have quite small screens, but the applications that you're using on those devices were designed for devices that can handle a higher resolution. So things maybe too small to see, buttons maybe too small to press, for example. And then we've got things like smart home devices. So these do increase the usability. For example, you might have an internal webcam or like a security system at home, like a digital lock, for example. So they increase the usability by giving you remote access, but they also decrease the security by potentially by increasing the attack surface. And many IoT devices do have inadequate security, especially cheap ones. A lot of these devices were built to be sold for as cheap as possible, and security in those cases was often seen as an extra expense. So human error. So humans are bad at evaluating risk, and according to an IBM report in 2021, the leading cause of security breaches with 95% was due to human error. So how do humans make errors? So how do humans actually think for a start? So there's this work by Daniel Kahneman, who won the Nobel Prize. This book with the image on the right hand side, it's called Thinking Fast and Slow. Some of you may have read it. If not, it's a really good read. Essentially, he breaks down human cognition into two different systems. So you've got system one, which is basically, you can consider this like autopilot, and system two is more slow, considered, a more considered way of analysing a problem before acting. So the vast majority of human activity is done by system one. So this is anything. So we it's what makes us efficient at working, and it is what makes us able to work on very complex tasks, right? So we get so the first time you perform a task, you will use system 2. So you'll deliberately and consciously go through all the steps, and once you've done that a couple of times, you'll have learned the steps, and it'll get ingrained into you. It'll become ingrained, and then in future, when you go back to do the task in future, it'll get taken over by system 1. So it's like more autopilot. It feels like more autopilot. So if you think about things like learning how to drive a car or ride a bike, we start out by using system 2 and being slow, deliberate, effortful, conscious of everything that we're doing, and that's a reliable way of doing things. And then after a while, we switch over to system 1, and most of it's just done on autopilot. It's quick, impulsive, intuitive. It's not conscious, it's subconscious, and it can sometimes be unreliable. So our over-reliance on system 1 it can lead to people taking advantage of the default processes that we go through. So this is apparent in things like phishing, social engineering, scams, all these kinds of things, trying to exploit people's the way people think and people's emotions. So positive security. So positive security is essentially a movement against the way that security is discussed and promoted, and the tactics that are usually used. So these are things like fear, uncertainty, and doubt. They're usually called FUD, or fear, uncertainty, and doubt. So they're things where people are essentially trying to introduce fear and make people feel uncomfortable, introduce a sense of urgency into by basically scaring people into compliance. So positive security is essentially a movement which thinks that this is not a good tactic, and that blaming humans as the weakest link is actually not a good way of doing things, because you're placing blame on the people rather than on the systems and procedures. So positive security essentially it inverts the idea of freedom from negative consequences, of like it basically changes the framing for the individuals from freedom from negative consequences to freedom to engage in valued activities. So how does it do this? So one way is by framing issues in positive language rather than assigning blame. Another is engaging stakeholders within the process and trying to increase their confidence and understanding in why we're doing the kinds of things that we're doing, and to make them feel like following the procedure is them contributing providing a valuable contribution to the business, the organisation, and that it's actually worth doing. So this is generally done by improving awareness, education, and training. So stakeholder engagement. So what stakeholders are, I mentioned earlier, are essentially they're anyone that has any interest in the outcome of a business, organisation, or a project's activities. So there's an image here with a bunch of different stakeholders. So it's not just people that work for the company. So you've got things like the customers, the shareholders and investors, so the people who own the company, any suppliers or other businesses that are interacting, that have business interactions with the organisation, the employees. You've got the local communities that are involved, government and public bodies, and NGOs, NPOs, and the environment. So these are some examples. And we essentially want them to be engaged with the process. That's the goal. So how we go about that is either attempting to increase the awareness, education, and training for these people, for the stakeholders that are involved. And some of the ways of doing this for regular employees, there have been studies. This is from the CyBOK chapter. That it lists a bunch of different studies that show that collaborative learning sessions have had beneficial results. And here's another thing from the knowledge area. So there's a section on software engineering and software engineers, and there was an interesting study by Akar et al. In 2016, and it showed that they essentially had two groups of software engineers, and they ran an experiment in which the software engineers either used like publicly available resources to learn about whatever the problem was that they were tasked with solving, and it showed that using openly available resources such as like blog posts and Stack Overflow, etc. Developers were actually 40% faster at solving the problems when compared to the group that stuck to official documentation, but they tended to produce less secure solutions than the people who stuck to the official documentation. So that's an interesting example of the trade-off, and it goes to show that sometimes people and organizations will choose to just work faster and be more productive. So awareness, education, and training. So these are the approaches that we're trying to use in order to try and rectify the situation from one end. The other end is obviously designing usable security. We also need to raise awareness with the general public, as well as whatever the group is that we're interested in raising awareness for. It might be a group of it might just be like local to the organization, or it might be just in general, trying to raise awareness of security issues. So this is essentially trying to persuade the public that security is worth engaging with. Following on from that is education. So after you've explained, after you've got people on board with the idea that security is worth engaging with, you might want to educate them on specific types of cyber risks. So maybe things like, for example, phishing or social engineering attempts, or scams, fraud, like online fraud. And then, after that, security training is more specific. So we're looking at how to develop skills related to either a particular security mechanism or a type of threat like phishing, social engineering attempts. Okay, thank you.